Good morning, and welcome back to another episode of watching me struggle to make a game. Is it educational? Nobody knows. Are we having fun? Nobody knows. What am I actually doing? Check. We decided last time that it was time to do a bit of tidying. I added a couple more notes to this when I'd finished, because I think in, again, kind of standard fashion. Oh, sorry, hang on. Oh. In kind of standard affair, I think I realised why our image allocation looks the wrong size as soon as we finished. I'm pretty sure we put in R32, G32, B32, A32 as our format, which is 4 times bigger than our actual thing, where we have 1 byte per stream, so, or per channel even. So we can go and change that quickly and see if it works. Then we want to refactor our sort of memory-backed resource usage. And then I think we're going to go through and look at how we do these image layout transitions. So I remember them being kind of painful. Until we refactor that into something more simple and easy to reuse. And then we want to go and... Oh, sorry. Oh. It's first thing in the morning, so I think my brain's not quite fully switched on. Body is protesting. What was I saying? Then we want to go and make our image view, and we bind it to a graphics pipeline, and then we'll be able to see what's actually in it. I think I've changed my mind on this one. I don't think that's a bad idea to embed the image into the file eventually, but I don't think it's a priority at this point. So, first thing we want to do is go and check our what's it format. So am I right? I make it R32. I did. So let's just check. If I go R8, G8, B8, A8. Do you want signed ints or unsigned ints? I think unsigned int. And we'll use compile mode. Odin run main. Get the path right. Failed to load the image because the path is wrong, which is why last time we found if I do CD to move it back 1. Am I being really dumb? Grab that, delete it, run it. Yep. That was being dumb. Maybe it's the risk of doing this first thing out of bed, but I think I've got a fairly busy day. I'm hoping to get some progress on this before everybody else wakes up. So we are on the clock. So that seemed like it worked. And I think it explains where that factor 4 difference is coming from. So I think it's good enough for me. We'll just call that good. Trash the binary file. Readme and renderer is all of this. I want to say fix image format. Cool. That was an easy one. Now onto the Meteor one. How are we gonna do all of this So which bit actually is it? So I guess the first thing to say is it's this. We've already done our sort of refactoring. So I guess this must be a... Okay, it's just an in-out that we've refactored. So one thing we could do is just pull all of it into a function as it is. Just for this memory requirement stuff. It's slightly awkward. Should we pull this into a function first? I wonder if it makes sense. Can I shrink this slightly and put a side-by-side view? Let's go open our VK. So if we add a get image memory requirements, just again, I think there's something about in-out variables, I think, which make it hard to read things. You have to start declaring variables when really they're return values. I just find my brain doesn't process them very well. So I think that's... what we've got here. Get image memory requirements. No V device. Colon V device. Okay, there's our first thing. So in here now we can say memory requirements just is VK get image memory requirements. It's just that little bit nicer. And then we've already got this thing pulled out, which is this one down here, to go and get these physical device memory properties. Desired memory type properties has nothing image specific to it. So I guess what we really want to say in here is find memory type index, which is going to be Vulkan related. So it feels like it makes sense to put it in VK. But it's also not... How do I explain this? It's not intrinsically just wrapping a call. It's actually implementing a bit of logic. And I wonder if that means we want to make a bit of a distinction in how we structure VK. How would we do that, though? Am I worrying too much? I might be worrying too much. I mean, it's what we were saying before. Directory-based packages makes it very easy to just add a new thing. What would it even be called, though? I also have a mine.odin, which is in package VK. And can I rename vk.odin, maybe? To vk wrapper.odin. How does that sound? So wrapper.odin is just wrapping functionality, and mine.odin is logic that I want. But it isn't tied to a renderer, so it isn't like it's our renderer's logic, it's logic that is reusable Vulkan stuff. Let's go with that. So let's have a get. What am I doing in here? Memory type index. That's the best description for what I can think this is doing. Is a procedure that will take in. What does it take in? Desired memory properties and device memory properties. So let's do, which way around do we want to do them? Let's do desired memory. Just be a little lazy. Desired memory properties will be a Vulkan. We're going to need to import vendor Vulkan. And here we can have Vulkan dot. Import v dot. Where am I looking? Memory property flags. And okay, get device. And we'll have memory properties. Which is of what type? It's just a struct. It's not a list. That's nice. Is a Vulkan dot. Oh my god, I was literally just looking at it. They're called physical memory properties. It will return something. I think it can fail. So I want an OK ball. And if it doesn't fail, we want the memory type index. Which will make a U32. It's currently not a U32. Because I was doing this -1 business, but this kind of is nice, so I'll wrap that -1 sentinel value into my OK ball. So what does this function actually do? Can we say for do we end up with a load of Vulkan results, or is it just our logic that can fail? I think it's just our logic that looks like it can fail. So let's do this then. So for memory, what is for memory doing? We're looking for memory type and index in that memory properties dot memory types. It's to be turned into a slice because it's not memory properties dot memory type count. That's another thing we could make nicer if we were doing a lot of it. Physical device supports resource type. Ugh, we're doing a bit of bit manipulation to work this out. Is this easy to understand? Memory. Oh, I've not got memory requirements. What's your problem up here? Cannot slice array. Memory properties dot memory types. Alright, do you know what? Let me save myself from bad typing. And just do a big copy paste. It's all this that needs to come in here. With tweaks, but that's the core of it. Okay, so memory type index is now going to be temp. My god, temp index And we forgot to pass in our memory requirements. Let's do that. Memory requirements. Which is going to be what type? Literally just memory requirements. Then interesting, it's getting angry there. Let's ignore that for now. Just assume it's something in here that's unhappy. So you are defined. Okay, let's find all the places that are calling memory type index, because they should all now say temp. Oh, something's going wrong. What is this? Cannot slice array. Memory properties. Value is not addressable. Interesting. And then that's why index and memory type don't exist. Value is not addressable. Memory types is an array. I don't get it. So memory properties is a physical device memory properties. Physical device memory properties. We do memory properties dot memory types. No, not a typo. Just looks weird. From 0 to so you can just do all of them. I'm so confused why it says they're not addressable. Cannot slice array. Value is not addressable. Can we go look that up? Are we looking Odin? Lang. Cannot slice array. For an operand X of type T. Is this something about the fact it's being passed in? Must be addressable, meaning that either a variable pointer in direction or slice or dynamic array indexing operator or a field selector. Got you. Okay. So it's not about whether it's actually an array that we can like index into. It's that. So if I shadow the name, I think it'll let me do it. Memory properties. Memory. Like that. And then it's happy. What a weird problem. probably means actually we're doing the wrong thing though, right? Because that's nasty. Should we just do like a for loop from 0 to the number and set memory type? So can we do memory type will be equal to memory properties, memory types at index, and then we can just say for index. I think you can do for loops like this, can't you? For index is 0, index is less than memory properties. Oops. Dot memory type count. Index plus equals 1. Is that not how you do them? My god, how do we look for loop? That's the first place he says it. For loop. Basic for loop. For. Oh, the type's not right. Can I make you a U32? Yep, the types weren't right. What's your problem now? Memory typo. Memory properties, memory types. Desired memory type properties. I was a little bit lazy and dropped that. And then temp index equals index doesn't work because temp index must be signed to use our sentinel value. There we go. So we probably could simplify that to not use the sentinel value. I don't know if we care enough to though. Alright, so we get to the end, and instead of panicking in here, we can now early return. And just because the sentinel value stuff makes this all wordier than I'd like, what does that actually mean? Is desired properties not supported? Else, we would like to return true, and memory type index will be, what am I looking at? Temp index cast to a int. Cannot assign value of temp index. Why not? Oh, I've put the cast in there. Because you have to be a U32. There we go, because I did the wrong cast. Jesus Christ, I made a meal of that, didn't I? So we look in here, we go through and we say memory requirements, memory properties, desired memory type properties. Get rid of all this guck. And we instead say memory type index is equal to get type index from memory requirements and desired memory type properties. I might swap those actually, which feels right, doesn't it? And memory properties. So we have kind of like the setup ones and then the one that we want. Angry. Get memory type index undeclared name. But it's right there. It's because it's in VK. There you go. Assignment count mismatch. Redeclaration of OK in scope. What do I say then? Found. Let's go with found. And if not found, we will say VK fatal. Memory type index not found. Desired memory type index not found. Do we want to just wrap that into the function? Because we have to do that every time. Maybe. I don't know. I still think it's useful reading down the pipeline to see each potential failure point. Maybe that's me being silly, though. Oh, yeah. Okay. I don't know. We're going to leave it like that for now. Let's just check. Doesn't blow up. Nice. And then if we come back, we can... Oops, wrong editor. So if I go and search now to find the next place that uses memory requirements. How do I just be like, ugh, my god, why am I so bad at this? Put that back. Stop it. Can I do a search for memory requirements getting declared? There we go. There's our next place doing it. And there's all our repeated code. So let's go ahead and do your all VK get memory type index for memory requirements and memory properties and desired memory type properties. And in here, I would like to say found. If not found, VK fatal. How about that? This is our first actual test because this was actually used and it doesn't fail. Good. Can we do the same thing again? We go find the next place, does memory requirements. Pull that all up, and again. This can now be memory type index. Is declared to be VK get memory type index from memory requirements and memory properties and desired memory type properties and oops. Oh, what does that do? Nothing. Okay. Found memory type if not found VK fatal. Proper TZ. There we go, get rid of that. And let's do one last check for anywhere that does memory. Oops, memory. Requirements. Space. There we go. We've got all three of them. Still builds. Still builds. Cool. I think that was a useful first step. Can we just jump back to the first one we did? Sorry, I'm yawning again. Okay. So that's slightly streamlined. Is there anything else in here? I'm going to just drop this to do for now. I think it's still possibly true, but it's not on our radar at the minute. Can we wrap all of this into a function? I guess it's only awkward because memory requirements isn't the same every time. And this bind isn't the same every time. We could have something like we could call a thing a resource where a resource is either one or the other. And then we could have a... Where would that start and end? I guess in here. Oops. Oops. Maybe like start of get memory backed resource. And I guess that would be the end. That might be worth trying. Everything else in there, I think, is the same between the two of them, right? It's just a question of... Okay. This might be a good excuse to go and remind myself how unions work in Odin as well. So let's do that. Drop that. Stage everything. Stage that as well. So we've done a rename. We've added our mine thing. We've updated renderer. Dropped a line from the README. Refactor. What actually did we do? Memory type index. Logic pulled out. There we go. Right, let's start another one of these then. So we're in here. What is that actually going to need from us? I'm trying to remember how unions work. So I think what we'd have is we'd have to say something like resource is defined as a union of v image or v buffer. And we're interpreting this as sort of like memory backed thing, right? It's a thing that is identified by an index and has memory associated with it that we will map, and we're just going to always persistently map all our memory. So if we do a get memory backed resource as a proc, are we clear what it would be returning? So we're kind of looking at this next chunk, right? One thing that is nice, it can wrap all of this. It can fail. So I think we'll want an OK ball and a res v result. Because it can fail in different places in different ways. We allocate. I guess I'm looking for places that I'm putting things on the renderer, aren't I? So yeah, like texture image memory. Can I have it say, I'll return a resource. That's an us thing that wraps either the image or the buffer. And a memory, which will be a v.device memory. And our memory mapped, which will be a raw pointer. I'm going to drop the result, I think, and just give you the OK. Just for simplicity. Alright. So actually we're wrong. The start of this is up here. Get memory packed resource. Actually, do we want that in there? I guess we're going to have you pass the resource in, though. The question is just how do we handle that resource? Okay, so get resource, backing memory. Allocate and map resource memory. Take a resource, we give you back memory bound to it and mapped. That feels not insane. And then its first chunk is really all of this. So let's whack that in there. And we can... Oops, can I remember how my keyboarding works? That one? So you don't have to say VK because we're in VK. You don't say Vulkan, you say V. And then there is no renderer, so this is all stuff we're going to pass in. Okay, so that is slightly interesting, right? 'Cause we want that to be able to take either. Which means this is going to have to be a new function. That looks like that. Memory properties equals get physical device memory properties. So we also need to pass into here. So we've got our resource. We're going to want device is v device. We're going to want physical device is v physical device. Cool. And we're going to want get resource memory requirements. To be a procedure that takes in a device and a resource. And I think we'll switch on resource. case. Is that how you do that? How do I switch on a union? Alright, let's go have a look, because I don't really... I'll be honest, I don't know if I've ever used a union in Anger. Type switch statement. Construct allows several type assertions in series. Type switch is like a regular switch, but the cases are types. For a union, the only case types allowed are that of the union. Switch v in value. What? Switch. Ah, you have to give it a thing. So switch R in resource. Case image, we return get image, memory requirements, device. Dar? Is that what that's saying? Doesn't look it, does it? Quite angry. Get resource memory requirements. Call does not return a value and cannot be used as a value. Okay, so you should return something. You should return this. Case v dot the other thing buffer. We'll go return get buffer memory requirements for device and R. And if you get to the end here, am I missing a curly bracket? I am. That's why it's angry. Christ, I made a bit of a meal of that, didn't I? But that generalizes it, right? I think there might actually be a built-in like function overloading thing. Explicit procedure overloading. Can we just do that? Okay, so let's... I always do that the wrong way around. Let's comment that out. What if instead we say get resource memory requirements? How do you do it? It's a proc curly braces and then all the stuff that you're putting into the overload is either get image memory requirements or get... What's that thing? Buffer. Ooh, that is nicer. I think that does the exact same thing. No procedures or ambiguous call for procedure group get resource memory requirements. Match with the given arguments. Okay, no, it doesn't do quite the same thing. Okay. Okay. Yeah, because in that case you wouldn't pass in the resource union, would you? You'd be passing in one or other of the types. And we don't know what type it is yet. Okay, never mind. I think that looks fine. Can't remember what we were doing. in here, we would like to say, if not found, early return. That does that. Then I think the rest of this can hopefully just be copy paste, right? Allocate memory. No, the binding stuff also takes a bit of thinking. Sorry, let me stretch. Oh dear. Okay, let's take this block next. Pop it in there. Alloc info. Close to just works. Texture image memory is now just going to be memory. And we don't need that anymore. We're inside VK. If not success, instead of that, we'll just early return. Oh, let's go back. Bang that out. Early return. Okay. So it does our allocation. Bind resource memory. You're gonna have to do the same shenanigans. Requires a device, a resource, and a memory. Let's go ahead and say v device and resource. And memory is device memory. It will just return, I guess, okay, and res, okay, bool. In fact, let's have it just return the result, because if we need that anyway. Is there any sense to how I'm doing this anyway? I guess we do that same switch. Switch R in resource. Case, image. We return Vulkan bind image memory for device and resources and image memory 0. You can just do R, can't you? There we go. Else case v dot buffer. Confused. There we go. Return v bind buffer memory device R memory 0. Lovely. Get to the end. I'm slightly surprised I have to tell it it's unreachable, because it knows the type and it knows that switch is exhaustive and it knows every branch returns, but apparently it doesn't. Well, I guess know is a funny word. The compiler could know. Alright. So then we take all of this and it goes in there. and it has the same stuff to change, so let's go and do that quickly. And renderer is not needed. Instead of bind image memory, we're going to say bind resource memory. For our resource, we're going to say memory and 0. I think we just didn't pass in the 0, did we? It's not a bind thing, is it? Bind. There we go. Bind resource memory. If not, success. We'll early return, I guess. And then we want to do the map. Oops. So we're in here, we can go grab the rest of this out over there. Like that. Map res. All of those. Get rid of all of those. You should now say resource. No. You should say memory. And that should say memory mapped. Grab all of that. And if not success, early return. We get to the end here and we can return true. Memory mapped. And then we'll say over here, get memory allocate and map resource memory. Cool. How do I make a resource? Can I just pass in renderer dot texture image? Presumably not. But I'm going to just leave it there for now. Renderer device and renderer dot physical device. Ah, it does work. Fun. And we'll go ahead and say, okay, renderer dot texture image memory and renderer dot texture image memory mapped. How about that? And we'll say here, if not okay, VK fatal, fail to allocate and map texture image memory. Check compiles fine. Nice. And I'm hoping that means this whole chunk now just reads more nicely. We create the image, and then we map the image. Cuckoo, cuckoo, and then we do this copy.
We could include the copy in our other thing, but I don't think it gains us very much. Okay, we're pretty sure we solved this, so let's bin this to do. Excellent. So yeah. Can we now... So one thing I found surprising using Emacs is because it's not like strictly modal like Vim is, unless you use Evo mode. It's very easy to accidentally hit the wrong key and start typing stuff when you think you're putting in commands, which I'm not going to lie, I don't love. Okay, so I think what we can do is we can replace a load of these blocks in here. So let's say allocate and map memory. I think I still like that because it means I can just use names like OK without worrying about trampling things. OK and renderer dot vertex buffer memory and renderer dot vertex buffer memory mapped is equal to vk dot allocate and map, where we would like to say renderer dot vertex buffer and renderer dot device and renderer dot physical device. So can we do that? It's annoying they can't be both. Okay, and then so if not okay, vk fatal fail to allocate and map vertex and buffer memory. Okay, I was unhappy having them mixed. I was sure you could do that. I guess you can't though. Can we then go ahead and say renderer dot vertex buffer memory vertex buffer memory and renderer dot vertex buffer memory mapped is vertex buffer memory mapped. And then that's a problem because we've not deleted all of this old code, which is there. Excellent. So create texture image resource. I might actually do the same thing. So create texture image resource is everything down to there. And then this is allocate and map texture image memory. And then this is copy texture image memory. Copy texture data. It doesn't work because it requires data from up here. Okay, yeah, that probably is more fuss than it's worth then. Okay, we can live with that. I think there's one more of these to do, right? Let's go find our index buffer. We create its thing. So I think all of this can go, all of that can go. And all of that is now okay. And index buffer memory and index buffer memory mapped is equal to vk allocate and map, and it will take renderer dot index buffer and renderer dot device and renderer dot physical device. If not okay, blow up. If not okay, failed to allocate and map memory. Failed to allocate map memory. Else renderer dot index buffer memory is index buffer memory. And index buffer memory mapped is equal to index buffer memory mapped. Beautiful. Well, I think that was well worth the bit of effort. So let's. In fact, maybe it's even nice to look at the diff. You can see all of this replaced, all of that replaced. Yeah, that's got to make it more readable, right? And then it's just shunted across into this other file. Are we upset at the resource thing? I think the resource thing is also a useful abstraction to keep, because there's a bunch of stuff that's going to be applying to either memory for image or memory for buffer. So I think that's probably actually a useful little distinction to keep in our code. What do I do in here? I said refactor memory backed resource allocation and mapping. It's persistent mapping because we're keeping them forever. Cool. Let's push that all up. That feels a good chunk. I might go quickly run. I think we have a format. Oops, sorry. Compile and do ./format and just check if that did anything. Apparently not. Cool. Right, let's go look at README. So we've refactored that out. That feels a good start. Grand. And I'm just looking at the time. I've got a feeling that my family are going to be getting up before I have time to go and refactor image layout transitions. So I think I'm going to make a clean cut here instead of starting and getting interrupted again. Let me just update README. Push that up, and we'll call that a day, I think. Hopefully I'll get time to do this other bit soon, and then we can get on to the actual interesting stuff. But hey, I quite enjoyed that. Kind of therapeutic to just sit and mindlessly bash through a load of refactoring. Grand. Well, have a nice day, and I'll catch you on the next one.